Awesome. Thanks, Ben. Hey, everyone. My name is Velida. I'm a software engineer and Microsoft Data Platform MVP based in Auckland, New Zealand. And tonight, or today, depending where you are in the world, I'm going to give you a very quick overview of Azure Cosmos DB. So Azure Cosmos DB is Microsoft's globally distributed multi-model database service. Using Azure Cosmos DB, we can build databases that use a variety of different data models. So we can build applications that use document data, and we can do that using either the SQL or MongoDB API offering. If you're working with columnar data within your application, Cosmos DB provides a Cassandra API. If you're working with key value data, say if you're using a lot of Azure table storage and you need to distribute that on a global scale, Azure Cosmos DB provides a table API, which is essentially Azure table storage on steroids. Or perhaps you're working with graph data within your applications, and for that you can use the Gremlin API, and you've got a graph database in the cloud. Now, Cosmos DB provides us with the ability to build highly responsive and available applications anywhere in the world, ensuring that our data that for our applications is as close as our users as it needs to be. And it comes with a lot of key benefits. So with the ability to replicate your data to wherever your users are, this is what we call turnkey global distribution. And you can add and remove any Azure regions to your Cosmos DB account at any time. And Cosmos DB will replicate your data to all regions associated with your account while your applications continue to be highly available. There's also elastic scalability of both throughput and storage worldwide. So Cosmos DB offers elastic scalability of your reads and writes all across the globe. And you can scale up from thousands to millions of requests per second. And you only need to pay for the throughput or the compute that you need to help deal with any spikes in workload. Cosmos DB also provides low latency at the 99th percentile worldwide. So this really helps us build highly responsive planet scale applications, and Cosmos DB guarantees less than 10 milliseconds latencies for both index reads and writes at the 99th percentile, which provides us with that ability to perform rapid queries and highly responsive applications. With Cosmos DB, we're no longer constrained to two extremes for consistency. So Cosmos DB provides precisely defined multiple consistency choices for us to choose from, depending on our application requirements. And right out of the box, there are no schema or index management requirements. There are some caveats with that, but out of the box, Cosmos DB automatically indexes all data and is schema agnostic, meaning that we don't have to worry about application downtime or managing schemas or indexes. There is quite a lot to this service, but for the purposes of this talk, I'm going to focus on a few concepts. So petitioning, throughput, which is compute, and global distribution. So let's go on to how petitioning works. So Cosmos DB uses petitioning to scale individual containers within a database to meet the needs of our applications. So every time we persist an item into a container, or if you're coming from a SQL background, it's really a table within a database, but in Cosmos it's called containers. So every time we persist an item into a container, they're divided into something called logical petitions. And these will be based on a value of a petition key that is associated with an item that we store within our containers. Now, items within a logical petition will all have the same petition key value, and this will be a property within our documents. So, for example, if I had a container that was storing items related to hotels, and we gave that container a petition key of city name, and we had 20 different city name values within our container, we would have 20 logical petitions created for that particular container. And these logical petitions are then mapped to physical petitions. And these are essentially just an internal implementation of the petitioning system that is managed by the Cosmos DB team. So for your information, physical petitions are just essentially a fixed amount of reserved SSD-backed storage and compute. Let's move on to throughput. Now, throughput is essentially how compute works in Azure Cosmos DB. and you pay for the throughput that you provision and the storage that you consume on an hourly basis. And as developers and data professionals, we need to ensure that we have enough resources on our Cosmos DB containers or databases at all times. When we make operations on Cosmos DB, we use something called request units. And if you go through documentation for Azure Cosmos DB, this is really referred to as RUs per second for short. And essentially what request units are, they're the currency for throughput. And this is just an abstraction of system resources such as memory, CPU, IOPS required to perform these operations. When we provision throughput in increments of 100 request units per second, and we can increase or decrease provision throughput at any time. When we perform different types of operations, the amount of request units that we consume vary depending on a variety of different factors. And these include how big the documents that we want to persist into our containers are. It also depends on what kind of properties within our document are indexed. And it also what consistency level we provide, and there are many different factors that escape my head. But depending on what kind of and also the complexity of your queries. So these vary depending on the request, depending on how complex your queries are, it will factor into how many request units you need to consume for those particular operations. And let's move on to global distribution. So today's applications are required to be highly responsive and always online. And to achieve this low latency and high availability, what we need to do, we need to have instances of these applications. They need to be deployed into data centers that are as close to our users as possible. So Azure Cosmos DB is a globally distributed database system that allows us to read and write data from local replicas of our database. And what Cosmos DB does, it transparently replicates the data to all of the regions associated with our Cosmos DB account. So Cosmos DB is essentially what we refer to in Azure as a foundational service. So it doesn't matter which cloud you're deploying your region, which region you're deploying your Azure resources to. You can deploy Azure Cosmos DB anywhere in the world. And we can configure our databases to be globally distributed and available in any Azure regions. And to lower the latency of our applications, it's really a good idea to place the data as close to our users as possible. Choosing the required regions depends on the global reach of our applications and where our users are located. So if we've got customers in the UK, we can deploy a replica of our Cosmos DB account to the UK. If we've got customers in Australia or New Zealand, we can deploy Cosmos DB to Australia and so forth. And with Azure Cosmos DB, you can add and remove regions associated to your account at any time. So we don't need to manage any downtime. We don't need to pause our application. We don't need to redeploy our applications if we want to add or remove particular regions to our Cosmos DB account. This is when we add regions or remove regions to our Cosmos DB account, this is managed for us, and our applications continue to be highly available and online. Cool. So that was really quick overview of Azure Cosmos DB in less than 10 minutes. Thanks for coming. If you do have any questions, feel free to reach out to me on Twitter. And thank you for having me.